Good afternoon. Welcome back to your review for your exponential quiz next Tuesday. We're continuing on to number 12, where we'll be looking at tables and determining if they represent exponential functions. And if they are exponential functions, we have to determine whether they are growth or decay and write an equation for the table when possible. So, first we have to remember, every exponential equation is based on the concept that from one value to the next, it grows or shrinks through multiplication. This is important. What you multiply by is the b of our equation. And we should remember from earlier in our videos, y equals a times b to the x is the general form of all exponential equations. A is the initial value or the y-intercept. B is what you multiply by over and over again, and X represents the number of times you multiply. So now let's look at our specific examples. So we look at time in months compared to dollars. At 0 months, we have $100, 1 month, 107, 2, 114.49, 3, 122.5043. So we have an inkling that this would be an exponential growth because the numbers are going up. But I have to make sure they're going up in an exponential fashion. What that means is they're multiplying from one term to the next every time. So the way to check that, take any term and divide it by the previous term. So I'm going to take 107 divided by 100. And I get 0.017. So what that means is 100 times 0.07, 1.07 equals 107. Now I want to see if the pattern continues. You can do it one of two ways. You can just keep dividing. 114.49 divided by 107 should equal 1.07. And it does. So now the pattern continued. So 7 times 1.07 equals 114.49. I need to make sure the pattern continues the whole way through the problem. So now I'm going to take 122.5043 and divide that by 114.49. And yes, I do get 1.07. The other way to check was, once you found your multiplier, just keep multiplying by it. What that means is 107 times 1.07, and that gave me my next term. Then I would take that term times 1.07, and I got my final term. Now, I have determined that it is exponential because to get from one number to the next over and over again, we multiplied by the same number. Now, the type of exponential would be growth because it's growing. So this is an exponential growth. Now the equation. Remember, we said all equations are made in the form y equals a times b to the x, where a is the y-intercept. When I look at the table, we're lucky they give us the y-intercept. At the initial value of 0 months, we started with $100. So a equals 100. And according to our chart, we were multiplying by 1.07. So my b, or my multiplier, is 1.07. That leads us to the equation y equals 100 times 1.07 to the x. And then x would represent the number of months. So if I wouldn't find out for any month, I would know what my account would read. So I have the equation y equals 100 times 1.07 to the x. So we've seen an exponential growth function. Now let's look at our next. We have a savings account, and it looks for every day that goes by, our savings account is going down. So you might think this is exponential decay, but we still have to do our investigation. We have to make sure that it is a repeated multiplication problem. So I take any term, 2,400, 2,400, divided by 2,500, and I get 0.96. So what that means is, from this term to this term, I multiplied by 0.96. So let's see if the pattern continues. 2,300 divided by 2,400 does not give us 0.96. It's very, very close, but it is not 0.96. So now we see that we have a different pattern. And we can check this one. 2,200 divided by 2,300. And we still get a different 9.95, but a different decimal. So what I'm seeing here is I do not have the same common ratio or the same multiplier over and over again. If I do not have the same multiplier, I am not exponential. This is not an exponential function. So this one is not either exponential growth or decay. And if you look at it closely, what's happening is you're going down by 100 every time. What we have here is a linear equation, and we studied those in the first semester. And if you remember, linear functions are y equals mx plus b, where m is the slope and b is the y-intercept. Well, our slope is going down by 100, so our equation for that would be y equals negative 100x, and our initial value here was 2,500. This is not going to be expected out of you on your quiz, but there will be a bonus question if you can come up with the equation of a line when it is not exponential. Now, on to the final one. This table shows us that for every day that goes by, the medicine in the body measured in milligrams starts at 192, then goes down to 48, then to 12, then to 3. So I know a lot of you guys are going to look at this and go, oh, I see the pattern. It's being divided by 4. That's not how you are allowed to look at these. Remember, we said exponents can only be demonstrated through multiplication. So if you say I'm dividing over and over again, you're giving me the wrong information. So I'm going to follow my rules and say, okay, I want to look at what 48 divided by 192 is. So this term divided by the one before it, and I see 48 divided by 192 is 0.25. So that means 192 times 0.25 gave me 48. I'm going to see if that pattern holds. 12 divided by 48 equals 0.25. That holds. 3 divided by 12 is 0.25. Or you can see it as 192 times 0.25 gave me the next term of 48. 48 times 0.25 gave me the next term of 12. 12 times 0.25 gave me the next term of 3. So now I have everything I need to write my equation. So I'll write my general form first. Y equals A times B to the X. A is my y-intercept or my initial value, and B is my multiplier. All my information is given in this table now that I showed my multiplier to the side. My initial value is 192. My multiplier is 0.25, so I have a decaying exponential, or I have exponential decay because I'm getting smaller, with an equation to represent that model of y equals my A value of 192 times 0.25 to the x exponent. So that wraps up number 12, looking at tables and creating equations. I will continue on in the next video.